Welcome. I pressed the wrong button. No, I didn't. Welcome back, everyone. We are on to the next session. We are going to be doing some C#. I haven't done that for a long time. And we're going to be going through some solid principles. Are we ready? Does everyone remember what the reaction buttons are? Does everyone know where the chat is? Make sure you do, because we want some interaction throughout this session. And Marlon, Michael, over to you.
Yes, thank you, Tanya, for that. Hey, everyone. My name is Michael Olatokun. I run an organization called Skillstruct, and today we are here to go through the solid principles using C#. For those who are, programming, this is something quite fundamental, especially from object-oriented, not just coding correctly, but also designing your code in such a way it's able to maintain itself for the long term. So you're going to learn some fundamentals. Obviously, we're going to be using Visual Studio Code, which you're welcome to kind of follow along with as well. I will be in the chat predominantly, so if there are any questions and things like that, whilst Marlon, who I'll introduce in a second, is going to present, and feel free to use that. We do want this to be engaging. We're also going to talk about as well towards the end how you can follow up with us if you have any questions about what you've heard today or you're curious about our organization. But yeah, we're here to help. We are technology educators as well. So for those interested in tech, we are a space for you. We've done some great work with coding Black females for a number of years now, and so we're more than happy to be here. And Marlon, who's going to be facilitating, I'm going to hand it over to him, but he's going to be leading this session today. Thank you, Marlon.
Okay, hi everyone, I'm Marlon Cumberbatch. So I work with Skillstruct as well. I facilitate a lot of the live events and online events as well. So I do talks on C#, and this will be my second one covering solid principles. So just let me know if you can see my screen when I start it. So yeah, so today we're gonna have a look into solid principles. Now, what are solid principles? So solid principles, it's a group of 5 design principles that helps make object-oriented software easier to understand, maintain, and be able to extend the functionality of the program. So if you think of like let's say a PS2, you'd be able to plug in controls into it, make modular items for it, for example, and we'll be going into that later on. So Solid was created by Robert C. Martin. So he took some ideas from that was built on earlier object-oriented design, so OOP. So OOPs is a big topic within languages like C#, as fundamentally you think about programming that way, so using models, classes, and functions to program that way. It's aimed to reduce code fragility as the system gets larger and the teams grow. It forms a foundation for clean code and clean architecture. So for example, if I was to go and work on a piece of code that I haven't seen before, I should be able to understand the code, and I should be able to see functions and be able to make my own function without breaking the whole system. And we will go into that later on as well. So each letter represents a different principle. So S, we have single responsibility principle. So the core idea is a class should only have one reason to change, and it should kind of only do one thing. So O, we have the open close principle. So the code should be open for extension and closed for modification. And again, we'll go into that later on. We have Liskov. So subclasses must be substitutable for their base class. And this is where some of the polymorphism will come into it, and inheritance. So we have interface segregation as well. So we use small specific interfaces to basically create a blueprint or a contract for the classes that want to use that. They will have to follow. We have dependency inversion principle. So this depends on abstractions and not on concrete implementations. And again, I'll go further into that later on. And towards the end of the session, I will give out a task as well so I'm going to be presenting an app as well that I'll be talking through. So you can either at the end make a plan with like maybe the UML diagrams, or if you have like a software to draw on, or maybe Word documents, or you can do it within the Visual Studio Code. Okay, so some reasons why Solid matters. So promotes clean modular design, makes code easy to test, reuse, and maintain, which is one of the important reasons. Can also reduce bugs when adding new features. Again, so when you are adding new features to a program in your workplace, you don't want to break the whole system, right? So stuff like dependency injection, when we'll get to later on, it will help you to understand. Encourage loose coupling and high cohesion. So basically, you don't want different modules to be tightly coupled. So you want them to be related, but by calling on other through other functions through like a constructor and a class. Support scalable architecture as the system evolves. So that's like kind of the core idea for Solid. And then now we're going to single responsibility. There's no questions at the moment before I go into it.
No questions at the moment.
No questions. Okay. All right, so here you see a code snippet, and I'll be showing you as well. So single responsibility. So a class should only have one reason to change. An entity should be responsible for one job. And in this snippet right here, so we have a function called create order, right? And here it's doing three things. Could anyone take a guess what we could do with this to make it follow single responsibility? Can they chat in the chat, or is there reactions?
Yes, I believe they can do both. But yeah, if anyone
if not,
does
I
have
can just carry on anyways.
Okay, we've got one. It's currently public. That is at the moment. Only do one thing, write to the database. Okay.
Okay.
So we've got a couple there.
Okay. Yeah, so at the moment, so this violates single responsibility. So what this class is doing, so here you can see it's calculating the discount. So this is the e-commerce app, so it's calculating the discount. It's also saving to the database. At this moment of time, we just have fillers such as like console.writeline. But when it's fully implemented, this would be saving to the database, for example, and then sending an email. So this would be doing logic persistence. So persistence meaning maybe keeping data or writing data or getting data, and then it's sending a notification. So now I will switch to here. So what we've done now is separated the order. So we have the model there. Can you see the Visual Studio Code?
Yep.
You can see it. Okay. Services. So here you can see we've made an email notifier, for example. So we separate it, and you see it's inheriting something, and we'll get into that later on as well. So we separate one of the responsibilities out. For example, order repository. So for example, this would be saving to the database, right? So we've now separated that into its own class. And then for the order itself, order service, as you can see here, it's create order. So it's changed from what it was before to this. So it's still applying a discount, saving and sending. However, through using the other letters, which we'll get into later on, and it'll hopefully make more sense, we've kind of just make them do separate things in the background, and then now this class is only responsible for creating an order instead of creating. Let me go back to the slide. Instead of creating the order, calculating the discount, saving to the database, and sending emails. So hopefully that makes sense. So to help this follow SRP, I've split the current code and refactored it into their own classes. So as you saw, the regular discount, there was a regular discount there, order repository, email service, and order service. And then the create order, you take these classes and you call upon them in that class, and then you kind of just plug it all together. So it's only responsible for creating the order, and it's not responsible for anything else. So if something does break, you wouldn't go back to the create order class. You would go back to one of these four classes most likely, where the issue was. So that's just an example of how you can take maybe a bigger function and split them up and only have the remaining function just plug and play basically. So that's just an example of that. So next we have open close. Now, before I talk about this, is there any question on single responsibility? If anyone's confused on anything?
Yeah, I mean, it'll be interesting to know, based on what you've just heard in the chat, how you describe single responsibility based on what you just heard. Feel free to use the chat. And I don't know if we can get any reactions to. I'm just curious as well, how many people use C# on a day-to-day or have used C# before? You can give some reactions or put it in the chat, just so we know our audience. Okay, yeah, SRP, Pauline said, should do only one thing.
Okay.
Yeah.
Yep. So you break the responsibilities into separate classes. So this will make it easier to test the classes that will come in the future. So for example, the order repository and the email service independently. And then when the invoice logic changes, so if we make any changes to it or add any functionalities, only the email service changes. So it won't affect the rest of this. And that's basically how we can kind of make a class that's doing several things and then split them up into other classes and kind of join the pieces and just have a single class that's responsible for maybe the higher level of it and not the lower level. So next we have open close principle. All right, so with open close, the code or class should be open for extension, but closed for modification, class or functions basically. So here we have a class called calculate, right? And what it's doing is trying to calculate a discount basically. Does anyone see any issues with this?
So yeah, based on what you can see on the text, is there anything that you can see from a design point of view that makes it a little bit flawed? I mean, what's your interpretation of what you can
just
see?
have a guess. Yeah.
Yeah. I mean, maybe just talk through what you can see on the screen. That could be a good start, or type what you can see on the screen. That could be a good start as well. That can help build out the answer a little bit.
So yeah, a little hint here would be, so we have two if statements here, and we have a type, so regular customer, and we have a type VIP customer. So what would happen if I wanted to add more types of customers?
So we've got from Pauline, should be able to add existing functionality without should be able to add new functionality without changing existing functionality. And then Lawrence said the types are hard coded in the function. That makes it hard to modify it. Is it closed? Is that the issue? And then we have to add more types. You need to change slightly the functionality.
Yeah, so basically, if we see a bunch of if statements basically chaining together, number one, you're always going to be going back, right, and going back to that function and changing it. So if we get another type of customer, um, maybe you get a discount if you're a student, right? We need to go back and change it. And eventually, when you have so many types of customers or types, you may end up running into an error somehow, and then it's just going to make it hard to find. So your main code is written to depend on the interface and sorry. So look for long if else statements or switch statements inside your code, basically. Um, every time a new condition or feature is added, you are forced to go back and modify the core code. So that would be breaking the open close principle. So this is high risk. So changing existing code increases the chance of introducing bugs and can break working features, basically. So what we've done here is now, if I go to the next slide, is separated the discounts into separate classes, right? So replace the conditionals with polymorphism, add new behavior by adding new subclasses, and it keeps the existing tested code unchanged. So I can go to it as well. So I have a base class now called discount strategy. So we made an abstract class. So with abstract classes, what we can do, if I go to no discount, for example, we can then override the functionality of this function right here. And this can only work if you have the abstract. So now we can have a parent class, and we can have each child class inherit the parent class, and then we can then do our function basically based off that. So for example, you can have 10% discount, you can have an 20% discount, you can have a 70% discount, for example, as long as you have the override available for your discount or for your certain class. So that's just an example of open closed. As you can see here, you can basically just carry on making new classes over and over again. And it's also one of the fundamental sort of ideas behind polymorphism as well. Being able to take one thing and use it many times, or make many different children based off it. And so polymorphism goes quite hand in hand with these principles as well, as you'll start to see, hopefully, if you're familiar with that. So when we're solving with polymorphism, so abstraction is the key. So later on as well, you can create interfaces, or in this case, an abstract class that defines the common behavior, right? And then instead of modifying a central class, you can now create new classes that implement the common interface or the function right here, the abstract function. And then your main code is written to depend on the interface, not specific implementation. So the appropriate code is called at runtime and depend on the object's type. So now, for example, if you go to the program, we have several different discounts now. We don't need to run all of them. I can now pick and choose when I want to use a discount. So I call discount strategy. And because a VIP discount inherits a discount strategy, it's now a child of the discount strategy. And I can now call an object VIP discount by itself, and then use that. And then we can switch it to a regular discount later on, for example. And just having the open close principle will create like a kind of plug and play sort of feature when you're programming, and you'll probably use this quite a lot when you're making APIs. You're going to be calling from a lot of controllers and a lot of service classes. You're going to be calling a lot of objects into those classes. So this is just one way to show open close principles, and hopefully when we give you a task later on, you can get up to open closed at least. Right, are there any questions before I move on to Liskov? Let me just read this out, and then so the benefits to your project. Sorry, I'm a little bit sick as well. your existing features are safe because you are adding new code, not changing old code. So this also makes the scalability very. It just makes it easy to handle new requirements and extensions, which future-proofs the architecture. So again, if you are maybe like a junior developer and you've been given like a task to go and develop a new function, right? Your function should be able to just plug into the system, not basically depend highly on something and break other pieces. So if something is broken on your function, it should really only be broken on that function itself, and it shouldn't really be touching other people's works or other functions. So also maintainability. So the code is easier to debug and test because each new feature is encapsulated. So encapsulation is it's an idea that within polymorphism as well. So it's encapsulated in its own class and following the single responsibility principle. Modularity, so it promotes more modular design. So again, this is sort of the plug and play sort of idea. So it makes it easier for new developers to understand and contribute to specific features without affecting the whole system. Now, before I talk about ListCob, does anyone have any questions?
We did have one, but I think I answered it, hopefully, Pauline. She was just asking what you meant by plug and play.
Okay, yeah. So when I mean plug and play, I'll just go over it again real quick. I say plug and play is so for example, when I mean like plug in, so we have like the base class, discount strategy, and from there we've made several different classes. And I have a faulty class here, and we'll go into this next. So for example, let's say this breaks, right? This faulty one could be broken. However, if it's not called up or it's not used at the time, it won't break nothing. That the program won't. There won't be an error. However, if I do end up calling it, if I design the system a certain way, so for example, it returns a -50, where it should return a double. It will, for example, if you made that rule, that means the system will break. However, at the moment, I can plug these in, and most of these won't have an issue with it. So that's what I mean by plug and play. You can kind of just swap them out and use them whenever you want to. For example, we've used VIP discount here, and then when we go down here, we've used a regular discount here with no issues. So yeah, that's what I kind of mean by when I say plug and play. So we have list-golf substitution principle. So with this, LSP makes sure that the derived classes behave like the parent class. So and it should not break the core behavior. So the objects of a superclass should be replaceable with the objects of its subclasses without affecting the correctness of the program. So a subtype should extend the behavior of its parent class without altering its expected behavior. So those are like a couple different wordings. Hopefully, you understood maybe one of those two wordings. So LSP is crucial for basically ensuring the powerful feature of polymorphism and works reliably in object-oriented design. The relationships between LSP and polymorphism, basically right now, is so polymorphism is a language feature that allows objects of different classes to be treated as objects of a common superclass. So it also tells you what you can do, sort of like maybe rules or a contract. LSP is a design principle that adds a behavioral guarantee to the polymorphism. It tells you what you should do by ensuring that the substitution of objects is safe and predictable. So, for example, I just showed the class as well. So the 40 discount is a child of the discount strategy. However, if I go to discount strategy here, so here it's saying that we need to return type double, and it also takes double as well. But in discount, info discount. So what we've done here is we apply discount, we overrid it, it's still a double. However, so basically what's here is saying is if it's less than 0, we throw an error, negative value is not allowed. We just made this to kind of show that it should throw an error basically, as it's not following the rules. It's returning a negative int. So basically returning type int instead of type double, which is incorrect. So this breaks LSP, as you you can't just substitute it out in and out of the program like the others can. This can be substituted in with no issues. As you saw in the program here, you can see the output here as well. They've just been substituted and it's fine. So that's basically the principles behind Liskov substitution. It's like applying a contract to your child classes, basically. Right, now before I move on as well to interface segregation, because it is kind of related to this one as well. If there's any questions I can go through. If you want to take notes as well, feel free to write down notes, because the task, what you'll be doing is kind of connecting these principles together and either coming up with a plan, or if you have Visual Studio Code open, you can try and program some of your ideas.
Yeah, I don't think we have any questions so far, I would say. But yeah, like I wanted to highlight, like I said at the beginning, this is more about the design of your program as opposed to, the logic or the syntax or the semantics of your program. I think it's a very important distinction. Obviously, with what we're trying to explain now, it's more about design best practices, really and truly, not sort of the beginner stage, which is why I put some of the polls in the poll chat, just as a FYI for those who haven't seen it yet, just to get a gauge of, one, how long you've been programming for, and if you've used C#, because I think that's important for us as well, so we can get some context when we're doing these talks as well, how we can do them too. So if you haven't filled out the poll, please do so. But yeah, so over to you, Marlon.
Yeah, on that point as well, so if I go back to the program as well, so technically there's nothing wrong with this code if you just look at it syntactically. Nothing's broken, there's no errors. However, it's not doing what I want it to do. Semantically it's different, right? It's going to return basically an error message, and I don't want that. What I want it to do is just, if it was I guess minus 50, let's guess if it was a 50% discount, right? Would have to do something like this, where you just times it by 0.5 instead, and that would be semantically and syntactically correct. So yeah, so in terms of like actual just raw code, there's nothing wrong with this, but the meaning of it, there's something wrong with it basically, and it breaks the expected behavior. Okay, so Liskov done that. Let's go to interface. So with interface segregation, no app or client should be forced to depend on methods it does not use. So this should mean splitting the large code blocks or task into smaller roles, basically, or smaller specific interfaces. So this encourages smaller modular components. It makes mocking and testing easier and prevents dependency bloat. So basically prevents tighter coupling. So again, so this would be like an example here where it's just doing too many things, as I showed earlier, and then I could show you that we've separated them into interfaces here. So we have in an interfaces folder. So for example, iNotifier. So it has a public interface iNotifier, and then we have a function there called send. So if I go to, let's say, SMS notifier, it's a normal class. It inherits the interface here. However, this has to follow the contract of the interface, basically. So if it doesn't have a send, there will be an issue because it's not implementing the interface. So now SMS notifier is basically a type of iNotifier. So just in this line though, we are writing to the console, and we can go to email notifier as well. It's also a type of ad notifier, right? So it has to have this send. So if you go here, look, you can see email notifier does not implement interface member ad notifier send. So we need to have a function called send. Otherwise, so if we didn't want this, then we shouldn't use ad notifier. So this is using interfaces is a good way to kind of create, let's say an ad notifier as a base, right? But we want to SMS, email, might want to fax or other ways you can send people notifications. You can build upon that. The same with order as well. So the previous class was responsible for doing 3 things as well. So now we've separated order into its own interface. So it's void at the moment because we're not returning anything. So we're saving. The function's called save. So for example, this would be writing to a database, and we have string and customer and a total. So the classes that inherit this have to follow this basically. So here we have the order repository. It's type or inherits an iOrder repository. So again, so we have the save function, customer, and total. So we have to follow this. Otherwise, if you don't, it's not going to work. So we just save to a database, for example. So just an example of how this could be used or why we do it this way. So this save, so think of save as like saving to an SQL database. If we wanted to save to different types of databases, we'll have to change the code inside because we'll be saving to, let's say, a MongoDB databases will save differently from a SQL database, right? So let's say we get more budget for the project and we want to create more database and have access to more resources. Well, we need to now, let's say we didn't have identifier before, now we need to go back here. Now we need to make an interface so that, oh, wait, if we do need to expand the business, we should have a base class which handles all that and make sure the classes that follow the exact same format in terms of the functionality itself. So yeah, again, the core idea is no client or app should be forced to depend on methods it does not use, right? And even if you go here, you can see anyways that go to the program, we don't have to use all of them here. We can call up whatever class we want or in the services at whatever time we need it. So in this instance, we have SMS notifier. Sorry, I'm sick, so my throat's scratchy if I'm pausing a lot. SMS notifier, and then we have an email notifier, and we only call them up when we need them. So that's kind of like one of the bigger reasons as to why you would want to use an interface. And then if you go back to the slides, talk about some of the benefits. Right, so improve maintainability. Changes to one interface will only affect the classes that implement that specific interface. No more ripple effects across your entire code base. So any class that inherits it, if you change the interface itself, then you'll need to go back and change the classes that inherit that interface. So just further down the line, when you have more classes throughout your project, working on big API projects maybe, and then you might have a lot of service classes which inherit a lot of things. If you change interface class, it will probably highlight all your classes. Oh, you need to add this new function into it, for example. So increased flexibility. You can easily mix and match interfaces to build new classes. So for example, if I go through it here, we have a vehicle interface, right? And let's say this vehicle drives and flies. And then let's say we make a car. A car can't fly, right? So we only want the car to drive. and the plane can't drive. We want it to fly. So to do this, you separate these two into an interface of its own, and then just inherit that only. So if you had interface car, for example, let's say we had like different types of cars, Jeeps, hatchbacks, coupes, and stuff like that. They'll all be a car interface, right? And then let's say we introduce a boat, for example. Let's say a boat floats, right? So we'll have to create a interface for the boat and then have a function called float. Yep. And then nowadays you're seeing a lot of cars that can drive in water. I don't know if anyone's seen it. So let's say we come up with a new car that drives on water. Then we'll take the car interface and a boat interface, for example, because you want to have the float function and the drive function. Are there any questions so far before I continue with the interface segregation? I'm just gonna explain like the last few bits.
No question per se about that. Just more, I was just talking to somebody about, you know, how you can, where you can use C#. So I was explaining to him that you can use it in all sectors, really. You know, finance, government. It's quite a popular language, actually.
Yes, popular. Yeah, game dev, everything.
Yeah, I feel it's kind of underrated, if I'm being honest. Actually, the poll results kind of show that, actually, because there are people that have programmed before. Most people have, but in terms of actually utilizing C# was quite low. So, you know, one of the reasons why we do a lot of these sort of sessions is, you know, to educate, but also awareness. There's so much opportunities within C# as well. Obviously, Microsoft is in all sorts of organizations, not to obviously mention OpenAI. You know, there's a relationship there. I mean, yeah, it's one of those languages which is open source as well. So it's definitely something that people should be aware of as well. So yeah, I think that was the main question, but there was no specific question around interface segregation principle.
Yeah. Okay. Yeah, because I'm also looking at the time as well. So but maybe the last part I'm gonna also just go through it and then give the task, and then hope if there's any questions I can help you know, fix up any explanations or worries that people might have. So just in general, so interface segregation, let me go over 2 more points quickly. Since interfaces are smaller and more focused, creating mock objects for unit tests become much simpler. You don't need to mock a dozen unrelated methods just to test one small piece of functionality. So you also have clearer contracts. So the contract is now simple and clear. Any developer can look at, for example, the iCar interface and know exactly what its purpose is. So again, you can see a lot of the principles are being combined. For example, like single here, open, close. You can make new things based on that. And then list cov as well. The car has to follow. It has to follow basically the parent class is the same. Then you have interface aggregation here. You separate things into interfaces. And then if we go to the next one, dependency inversion. Okay. So here you can see quite a bit of code here. So high-level modules should not depend on low-level modules. And this could be an example of it. So high-level modules. So for example, in this picture, you can see here that the actual implementation for the code is not done here. This is, again, I'm going to use the term plug and play, but you can see we're calling in objects, we're calling in the interfaces. We activate them in the constructor, and then all we have to do is just call up the things when we need them. So order.total, and we just want to apply a discount. We don't care. So this create order class does not care which discount it is, because it can use any. So you can call any discount from there, and it takes a type order. So same with the save. If we have multiple databases, it doesn't care which one, because the functionality would be made already in a separate file, right? And the same with send. So the whole point of dependency inversion is just splitting up everything. So when it's actually time to connect them all the pieces together. You don't have to actually implement the functionality in that specific, let's say, class, or if you have more than one file, right? You can just call on the pieces that you need, connect them together, and if there's any issues, you'll probably be able to like look at what highlight something here. Oh, apply discounts isn't working. It might say red here, and it might show you, oh, faulty discount.cs is not working, for example. In a typical application, a high-level module like your main business logic, for example, might depend on a low-level module like a specific database class. So this can create a fragile and tightly coupled system, right? If you want to switch databases from, for example, SQL to a NoSQL database, you may have to modify your core business logic, which violates the open close, first of all, and it also makes your testing more difficult. So your business logic can't be tested in isolation because it's hardwired to a specific real database, making unit tests slow and unreliable. So that would just be sort of like an example of explanation, like a more of a business setting of why you wouldn't want to do it. And so even here, all the service at the moment does not know or care which repository or notifier is used. So if you want to just see the actual code itself here, we have the module order, so it takes a type order, right? Order service. So a lot of the times, if you're using or if you name a class service, you're going to be calling upon a lot of maybe different pieces that you made in the lower end of side of things to then create functions to then use in the front facing side. So for example, in an API, you'll have a lot of service files where you would have made like a bunch of functions, for example, to like save to a database to create in this e-commerce example, create an order, and then the front facing side, for example, like an API controller, right? Or in this case, the program, you would use it here. So you have a service class and you call up the functions when you need them. And these functions will have a lot of stuff behind it that the program wouldn't care about. So when I mean that, so this class or this file itself wouldn't care about. However, all the functionalities are done for you already. Sorry. Let me just continue. We're almost at the end as well, and I'll give out the task. Right, so just a quick summary. So again, single responsibility, and only one reason to change. So this could be the order repository and email notifier, open for extension, and then discount strategy subclasses. So list of substitutional subtypes, regular discount, VIP discount, even the faulty discount will break it. Some more interfaces, right, for interface segregation. IDE repository, iNotifier, dependency ejection, depends on abstractions, order service constructor. And just for the task quickly, it is no questions, Michael, right? I can't see the chat as well, so.
Sorry, no, I don't believe so. If you do have questions, do please put it in the question tab so we can answer it. So I could be answering as well, but we don't have any questions as we do kind of start to round up.
Yeah, we give you finish up. Okay. So just for the task, if you want to do this or actually try and make a program, something similar to what I did. So come up with your own example of solid principles in a business setting, either using your own example or you can use like one of these following examples. So like a restaurant menu system. So for example, for this, you can think about how you can separate maybe the drinks from the meat and the starters and the mains, for example. E-commerce website, maybe sort of something similar to what I did, or how you separate different items into different branches, for example. Then a pet store, similar thing. How can you separate all the different pets and all the different things you can get from a pet store, and the business, maybe even the business functionality behind it, and try and separate them into like models, functions, interfaces, maybe parent classes as well, and the child classes. So you could try and make a plan for the selected example that follows each step of Solid. So think of any classes, objects, and interfaces you can use within the selected example. And then for a harder challenge, you can try and connect these together with a service class, just like I mentioned earlier, like a service class, maybe pulling from all the different classes and interfaces, and then trying to implement like a, for example, I had there create order, or that you can use further later on. So creating some resources to help you with programming in general, and hopefully with this task as well. HackerRank, Udemy, GitHub, Stack Overflow as well. If you're stuck, I know AI is around, but sometimes it's good taking a look into Stack Overflow, maybe doing some stuff manually will help. It can help you learn before you start using AI. Try not to rely on it too much for everything. YouTube, there's tutorials as well all over YouTube, even on Solid as well. If you want to go have a look at some and help yourselves understand as well. Got Solo Learn as well. So if you're new to a language or new to programming, you can learn from scratch at Solo Learn. Tutorials point. If you don't remember how to write like a function or a class, for example, you go to tutorials point and you can find out for yourself as well. Not everyone remembers how to write everything, just straight from their head off by heart. And then here we have the QR code to the Discord. Michael, if you want to talk about this section.
Yes, thanks, Mark. So I just put in the chat as well a link directly to our mailing list. But if you scan the QR code as well, and you're interested in getting more support based on the kind of stuff we do a lot of code sessions as well, both in person and virtually on Discord. So if you are interested, first step would be to scan the QR code. You'll see different links, but one of the links you'll see is join our mailing list, which I've also directly put in the chat as well. So if you are interested in that, let us know. Marlon, if you can also put the task up again, that screen, that's all right. So if people want to take a screenshot or anything like that of the task, please do so. And then as you are working on it and you need some support, best way is to join our Discord if you want further support and guidance. So yeah, fill out the form on the mailing list, take a screenshot, take a picture of this, and then if you want further support on this, help you lot on your C# journey, because I can see a lot of you have not used C# before, but you have programmed before. So I'm guessing without asking, Python's probably a language you maybe use, maybe even Java.
JavaScript, probably, yeah.
Exactly.
I started on a JavaScript, Python, and stuff as well, and a similar thing where I moved to C# and rules we have to follow, and
Yeah. Exactly. Yeah, I know that very well. So
Solid. Yeah.
So I appreciate everyone. This isn't obviously your first language that you have started with. Obviously, we can see Natasha in the chat put Python and SQL, which are common things as well. I've worked with Python and SQL myself. I code in both. So, these are the kind of sessions we do actually, Python and C#. So it's either going to be a Python version of this or a C# version of this. But yeah, like I say, if that is the kind of thing that you want support on, make sure the first step is follow the QR code, which was on the screen. If you could put that back on. And also, if you don't fancy just doing the QR code on the screen, feel free to just add our main list with the URL in the chat as well. Cool. So I think that's the main bits I had. Obviously, I know there's like a break coming up. So if people are looking to work on this and want to reach out to us, totally fine. Feel free to, again, like I say, the mailing list. But I also want to give the opportunity for people to ask questions as well. So if you do have any questions, again, feel free to put the questions in the question channel. We'd love to answer your questions. But if not, obviously, we appreciate your time here today. Some of you may be in person tomorrow. I will be there giving a talk at some point during the day, so I'll probably see a lot of you there. But if you want to continue the journey, learning C# and Python and other things like that as well, the best way is to join our community on Discord. But yeah, I think that's all I have to say. I don't think there's any questions. Tanya, I don't know if we hand over to you.
Yeah, you can hand over to me. Thank you both so very much. Can we get a virtual round of applause, please? And Paul Marlon, please go and rest your voice now. You did an incredible job. Never would have guessed this is his second time doing this presentation. It was amazing. Thank you so much. And everyone here, if you're interested in Python, C#, SQL, I guess any programming language at some point.
Yeah, relatively,
yeah. But mostly, JavaScript, Python, C#. Yeah.
Basically, join their mailing list and tell them what you want to learn, because they might, in the future, build something for you. You never know. But definitely join the... Michael's like, no.
No, you never know. I was trying to tease.
But definitely join their mailing list, become part of their community as well. Don't have to just stay with Code of Black Females, join all the communities, whatever one's relevant for you in your journey. But again, thank you both so very, very much. It was a really useful session. Thank you.
Yep. Thanks for having us.
Thank you for having us. Appreciate it. And we look forward to continuing the partnership for Code of Black Females.
Yep.
And everyone, we don't have another session in this stage until 3:45, but in 5 minutes' time, if everyone could please go to the Common for All track stage, and there's going to be a workshop or talk with Amazon. Let me get the name correct. It is Positioning for Opportunities in the AI Age. Something that's probably useful for all of us to know. So if you could all take a quick stretch break and then head over to the Common for All track stage and be part of that conversation. And I'll see you all over there.